Hi students, welcome to my YouTube channel. Here I will upload mathematics related videos. Kindly click on the bell icon to get notified. Hi students, today we will discuss about the Hermition and skew-hermitian matrix. It is a very important topic, very basics. What is complex number, its conjugate of a matrix and transposed conjugate. Write down complex number equals to z is equals to x plus iy. It is complex number. X and y are the real values. X and y are the real values. X is the real parts, y is the imaginary parts. Write down x and y are the real values. X is the real parts and iy is the imaginary parts. Its conjugate. Next, its conjugate z bar. Take conjugate z bar equals to real parts is as it is x minus iy. Its conjugate take negative part and conjugate of a matrix. Next, conjugate of a matrix. Complex conjugate of a any matrix is example 7 2 plus I 8. It is 2 cross 2 matrix and real numbers is as it is real numbers and imaginary numbers will take opposite sign. Real numbers are as it is 7 and 8. Imaginary numbers will be take opposite sign. Take 2 plus I, 2 minus I. It is only I. Take minus I. It is a conjugate of a matrix A. Next, transposed conjugate. Transposed conjugate denoted by a theta or a to the power of h is a transposed conjugate. Example, take this example 7 2 minus I minus I 8. Next, transpose of a matrix. What is a transpose of a matrix? Row changes to column and column changes to row is called a transpose of a matrix. Transpose of a matrix. First row becomes first column 7 2 minus I minus I 8. It is transposed conjugate. It is very important. Complex number z equals to x plus iy. X and y are the real values. X is the real parts and iy is the imaginary parts. Its conjugate x becomes as it is minus iy. Conjugate of a matrix. Take one example. 7 and 8 as it is. Take positive term and becomes negative terms 2 minus I. It is only I minus I. Transposed conjugate denoted by a theta or a to the power of h. And example, take 7 and 2 minus I minus I 8. Transposed of a matrix. First row becomes first column, second row becomes second column. The very exact definition of Hermition matrix, very important. First take Hermition matrix definition. A Hermition matrix is a complex square matrix. A Hermition matrix is a complex square matrix that is equal to its own conjugate transpose that is A equals to A theta. A conjugate whole transpose is called a Hermition matrix. A Hermition matrix is a complex square matrix that is equal to its own conjugate transpose. A equals to A conjugate whole transpose is called a Hermition matrix. In other matrix we take real numbers. In Hermition matrix we use complex numbers. Example, take down the example. Example, A equals to 4, 3 plus I, 3 minus I is 9. It is 2 cross 2 matrix. The real numbers, it is a real numbers, it is a complex numbers, and take transpose. A transpose, first row becomes first column, 4, 3 plus I, second row becomes second column, 3 minus I, 9. It is A transpose. Next take A conjugate, A to the power of theta. A conjugate, real numbers are as it is. A conjugate 4, 9, 3 minus I, 3 plus I. It is A conjugate. Next, A conjugate. A becomes this only. Take A conjugate. Real numbers are as it is 4 and 9. Then A conjugate, take 3 plus I, it is a 3 minus I, 3 minus I, 3 plus I. Next, A conjugate old transpose. A conjugate old transpose is equals to first row becomes first column 4 3 minus I. In the second row becomes second column 3 plus I, it is 9. It is A conjugate old transpose, that is A equals to A conjugate old transpose is called a Hermition matrix, or A conjugate is equals to A transpose. It is A transpose, this only. Take it A conjugate. It is same, that is A is the Hermition matrix. The second one, skew-hermitian matrix. Take down the heading. Skew-hermitian matrix. Definition: a square matrix. Write down. A square matrix is a skew-hermitian matrix. Skew-hermitian matrix if it is equal to the negation of a complex conjugate transpose. Negation of a complex conjugate transpose is called a skew-hermitian matrix. Negation means negative time. Negative negation of a complex conjugate transpose, that is A equals to minus, take minus sign, it is negation, A conjugate old transpose is called skew-hermitian matrix. The entries on the diagonal of a skew-hermitian matrix are always pure imaginary or zero. It is very important. The entries on the diagonal of a skew-hermitian matrix Hermition matrix are always pure imaginary or 0, pure imaginary or 0. Take down the example A equals to first row 4i 3 plus I minus 3 plus I 9i. It is 2 cross 2 matrix. Take A conjugate. In the first row 4i, take minus 4i, it is 3 plus it is a minus I. In the second row minus 3 is as it is a real value, and plus I is a complex number. Take minus I, it is a 9i minus 9i, it is a conjugate. Next A conjugate whole transpose. Transpose becomes row becomes column, column becomes row. In the first row, take first column minus 4i 3 minus I. In the second row becomes second column minus 3 minus I minus 9i. It is a conjugate whole transpose. Negative minus is a take it common. First row 4i and 3 plus I. In the second row minus 3 plus I 9i. Negative common is equals to minus A matrix. A matrix and minus A is the same. That is A is equals to negative times of A transpose, A conjugate whole transpose is called a skew-hermitian matrix. Very important note. Take first note first Hermition matrix note number 1, diagonal elements AII is equals to real values. In the second note, non-diagonal elements is equals to real or complex values. Real or complex values. The second one, skew-hermitian matrix. Skew-hermitian matrix. The first note, diagonal elements. Write down diagonal elements AII is a real part is equals to 0. The second node, non-diagonal elements is equals to real or complex values. Thank you, students. Thank you, one and all. Have a nice day. Good day. Thank you.